Now, membranes. When we look at the tissues of the body, like we've done with this chapter, in some cases, we're going to have all those membranes be present. And when we look at the membranes of the body, we classify the membranes as being either mucous membranes, serous membranes, synovial membranes. When we talk about the mucus, just like the name implies, goblet cells are going to be present. Do you guys remember the upside down wine glass? Okay. Goblet cells will be present because they've got to produce the mucus, and then we've got to secrete it. So this type of membrane is going to be found for anything that's leading to the exterior of the body. So if it's an opening to the outside of the body, a mucous membrane is lining it. Respiratory, digestive, urinary, and reproductive systems. When we talk about serous membranes, they're usually going to have a fluid that they can secrete. They're to the inner parts of the body. It's not something that's reaching the exterior parts of the body. The serous membranes, they are simple squamous. How many layers is that? What style or what shape? The fried egg. So it's a single layer of the fried eggs. We term it mesothelium because it's in the middle. Meso means the middle. So it's to the inside. They're going to have a basement membrane and some loose connective tissue, like the areola that we mentioned. Okay. Pericardial. What is that telling me where it's found? And peri tells me around. So around the heart. What is the plural? The lungs. So we're going to have this surrounding around the lungs. How about peritoneal? Where's that? That's going to be your abdomen, the abdominal, and then the pelvic. A synovial membrane, where you find it, freely movable joints. Any idea what we would consider a freely movable joint in the body? Shoulder, sort of. Your knee. Knee is a really good example. They produce that fluid that's very rich in hyaluronic acid. Do you happen to remember the hyaluronic acid and what it does? Lubricate. It's a viscous material that gets secreted, and it's lubricating that area. So these are going to be the membranes that we see with some of the tissues of the body. Now, all of these tissues of the body, whether I'm talking to the outside or to the inside, can be damaged. The damage can be in many different ways. However, we respond, the body, okay, responds to the damage. The immune response pretty much is going to be the same depending upon the type of damage. But one of the things that happens when we damage the tissue, think of cutting, like getting cut. I used the paper cut as an example. Think about a bruise. Think about having the surgery, whatever the case might be. Usually, we get some redness in the area. some heat, swelling, some pain, and depending upon the damage, we can actually get some disturbed function in that tissue. The chemicals that come into play, we can have histamine. What do you normally associate with histamine? An allergy reaction. But inflammation, because I mentioned a cell early on when we were talking about the matrix of connective tissue. Okay? I mentioned a cell called the mast cell. Go back and check that one out. Okay? Because that's not only important here, it's important with our immune system. So the mast cell releases histamine. We have kinins, prostaglandins, leukotrienes. All of them are going to have a specific job to do. Now, one of the things that will happen when we get tissue damage, we have throughout the, well, for the skin, okay, the pain that we will get from the tissues to the inner portion of the body, it's going to manifest in a different way, okay? But when we have the skin, which is our, in between the external and the internal environment, we got pain receptors located all throughout the skin. So when something happens, it stimulates that receptor. Information will go to the area of the body. Did I say brain? I said body. What? Not everything has to come from the brain. Some of it can come from the spinal cord. But anyway, it has to be registered, and then we begin to have a response. When we breach the internal environment to the external, like a cut, for example, certain things take place. When you cut something, okay, the way that we know that there are teeny, teeny, tiny microscopic vessels, the capillary beds, okay, that they're there, is because we bleed. So if we do something like a paper cut, which is not really cutting into artery or anything like that, we're simply cutting into a capillary bed, okay? But the process that has to take place has to follow a certain set of steps for the repair to occur, if that makes sense, okay? So what we want to make sure happens when there's a breach, we increase blood vessel permeability. What exactly does that mean?
Blood vessels to be more permeable so it can secrete.
Okay, we want those blood vessels to open up the way that things can move out of those blood vessels. So we want those white blood cells, for example, to be able to move out quickly, because we have breached the external to the internal, and we're now vulnerable to anything that's going to try to enter at that point. So we want to rush anything from those white blood cells, okay, which are going to be certain cells that'll get there first. We want them to get there and help us fight anything that's trying to come in. So we want the blood vessel to be more permeable, more open, okay? So, what happens? Splinter. That's the example that they're giving us right here. Now, we get a splinter whatever the case might be. We get that splinter, and what has it done? It has breached that layer from the external to the internal environment. Chances are we probably don't think about it being that detrimental, right? Depending on the size of the splinter, okay, you can just pop it right back out, okay? Or, you know, some people get the little tweezers, you know, that sort of thing, depending on the size of the splinter. And for the most part, you just go on about your day, right? Don't even think about it. Guess what is thinking about it? Your body. All right? Because it's like, hey, whoa, time out, okay? We have breached. We've been breached. It's like little alarms go off, okay? Because if we breach from that external to the internal, look at what we've exposed. Most likely, we've broken blood vessels. Now, we've broken through the layers of the skin. Depending on the breach, okay, they're actually showing, you know, lots of damage that's taking place in the dermis. So, when we have our blood supply, okay, we have the stuff that's flying around in the blood, because that's what it's supposed to do. And do you happen to remember one of the things that I mentioned, lining or just outside of our blood vessels were the mast cells? Mast cells from the white, you know, from the immune system are present, okay? They're going to help, all right? Now, because we've been breached, blood vessels get more permeable, meaning the little pores that are present open up a little bit more. Now, over here, it's kind of cool, okay, because they're kind of showing stuff that's moving out of those pores, okay? But down here, one of the things that they're showing us with the green dots is the bacteria that's now been introduced into the breach. Don't normally think a whole lot about bacteria. Well, do you? Or in a case like this, where you just simply did a splinter, do you think a whole lot about bacteria that you introduced to the body? No. Shouldn't? Why should I be a lot more concerned about it now than when I was like 3 years old? Well, we have created our superbugs. They only need one little entrance. So, should be a little more concerned now about those bacteria. So, those bacteria I've kind of introduced into this breach. Well, I didn't introduce it, the environment did, okay? And plus, we're being attacked 24/7. But anyway, that's beside the point, okay? So, bacteria have now gotten introduced. In our cells, we have, from the white blood cell group, okay, the immune system, we have some cells that are ready to attack as soon as this occurs. And they're trying to show them here with the neutrophils, okay? Neutrophils and monocytes are going to come in and be our first defense, okay?